Good morning, students. In the last lecture, we have completed up till question number 8. Now we are going to start this topic, conversion of solid from one shape to another. We have studied that for during conversion of one shape to another, the volume of the solid remains the same. Suppose for this question, a cone of height, example 8, the cone of height 24 centimeter and radius 6 centimeter is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. A cone of height 24 and radius of base 6 centimeter. Cone of height 6 base 6, height 4 base 6 centimeter, 24 centimeter. Volume of cone is 1 by 3 pi r square h, where h is 24 and r is 6 centimeter. The clay is used to make a sphere. Now this Vc will be equal to volume of the sphere. And what is volume of sphere? We know that volume of sphere is 4 by 3 pi r cube. Remember to differentiate this r and this r. These are not same, which implies 1 by 3 pi r square h. And one more thing, never find this Vc, because this pi and ultimately this pi will get cancelled and some other factors will also get cancelled. So just write from Vc 1 by 3 pi r square h and volume of sphere is 4 by 3 pi r cube. R cancel, sorry, 3 cancel, pi to pi cancel, and r equals cube root of r square h by 4, which is nothing. What is r? 6 into 6. R square is 6 into 6, r is 6, so r square is 6 into 6, h is 24 by 4. 4 6 is 24, 6, 1 times 6, 2 times 6, 3 times 3, and this is cube root. The capital R is 6. See, so simple. And if you have calculated this 1 by 3 whole this 1 by 3 pi r square h, then it will take more time to solve this question, and paper you know that there is very less time to solve. Now next example we will do as fast as we can. Selvi's house has an overhead tank in shape of a cylinder. Overhead tank in shape of cylinder. It is filled by pumping water from a sump, an underground pipe. There is a sump pump which is in underground. It is shape of a cuboid. Overhead tank is a cylinder and underground tank is a cuboid. The dimension, the sump has dimension, the underhead tank has dimension this, the overhead tank has radius this and height this. Find the height of water left in the sump after the overhead tank has completely get filled. See, it is assumed that this is length, breadth, and this is height. Always LBH. See, there is a sump pump, or you can sump tank, completely filled with water. And this is used to fill a tank. You must have seen at your home also, something like that. 1.57 suppose I will taking an A, B and C. This is A, this is B, no, and this is C. This is R, this is H. What we have to find the height of water left in the sump after overhead tank gets filled. How much height will be left? See, let's suppose the water which is going to fill here from this cuboid, the water left in this tank, the volume of water left in this tank, what will it will be equal to? That is volume of overhead tank minus volume of cylinder. Why volume cylinder? Because the water which comes out from this overhead tank or underground tank, sorry, not overhead tank, underground tank, will be equal to the volume of the cylinder, because it is going to completely fill this cylinder. Now now this volume, suppose this much only h, let us suppose that this is h dash, and this h dash is the actual height of water, remaining water. I'm assuming that this is h dash will be equal to volume of underground tank dash vt ut dash. Now what is ut? A into b into c. You know the volume of cuboid is length into breadth into height, minus what is the volume of cylinder? Cylinder is pi r square h, will be equal to volume of this h dash. What is a? Now we have BSc, no, c, length breadth into height. Length, let us assume that this is not the height, this is a, this is a, this is b, height is c. Question is given a into b into c. I am assuming that this is length, breadth and height. Length, breadth and height, c. So it will be equal to, and this is h dash, so this h height will be h dash, volume will be h dash height into base area a to b. This is known, this is known, this is known, this is known, and this. And if you want to find h dash from here, you can see that h dash a into b equals a b into c minus pi r square h. From here h dash equal to a b c minus pi r square h by a into b, implies h dash equals, not z, here you can ab c minus pi r square h by a into b. Simply when if you put the value, we'll get the answer. Therefore the capacity of tank is half the capacity of the sump. Original height by 2. A copper rod of diameter, next question, the copper rod of diameter 1 centimeter, diameter 1 centimeter means radius will be 0.5 centimeter. And yes, remember to always to write dimension here. If it is centimeter, centimeter, or meter is meter, or millimeter is millimeter. Copper rod of diameter 1 centimeter means radius is 0.5 centimeter, length 8 centimeter. Since this is copper rod, will always assume that rod is a cylinder, is drawn into a wire of length this of uniform thickness. Find the thickness of the wire. C. Again same thing. This much is, I'm assuming this is the rod or of diameter 1 means radius will be 1 by 2 or 0.5 centimeter, and height and length of the rod is 8 centimeter. Is you to draw wire of length 18, this thickness of the wire. See, if you want to find thickness of the wire, see, this is the length of the wire, thickness will be this, and this is nothing but d. D means diameter of this, which is equal to 2 into r. Here r is for this, or you can say d dash r dash. If I take r radius to be this and diameter of this is this, then d dash will be r dash into this, and length is 18 centimeter. Length is 18 centimeter. This length is nothing but the height. Here length is nothing but the height of the cylinder. So if you this is completely used to drawn into wire, which implies a volume of original rod equal to volume of wire. What is volume rod? Is pi r square into h dash. Pi r square h. This is not h dash. Pi to pi get cancelled, and if you want to find r is nothing but r square h by h dash under root. Nothing but r is r h by h dash. If you simply put the value, that's solve for you. 0.5 root, what is h? H is 8 by 18. 2 4 the 8, 2 9 the 18, under root 4 by 9 is 2. R equal to 0.5 into 2 by 3. A hemispherical tank. Next, a hemispherical tank full of water is emptied by a pipe. Hemispherical tank is emptied by a pipe at a rate of this liters per second. How much time will it take to empty half of the tank if it is 3 meter in diameter? See, nothing to worry. 3 meter in diameter. T is given 3 meter. Radius will be d by 2, 1.5 meters. Means this is a hemisphere called tank. 1.5 meters, and height also is 1.5 meters. Volume of hemisphere will be 2 by 3 pi r cube. R is there, put this value, get done. This is the volume of the sphere. Now the rate of per second, at the rate of this per second is getting emptied. How much time will it to empty half the tank? See, this volume of hemisphere is volume of this volume of this tank when water is full. See, in the question it is we have to empty half the tank, which implies a half of VH will be 2 by 3 into pi r cube into 1 by 2. Nothing but 1 by 3 pi r cube. Now this 1 by 3 pi r cube is to be completely emptied, because this half of this volume, this will be completely emptied at a rate given here, 3 4 by 7, 3 4 by 7, which is nothing but 7 3 21, 21 plus 4 25 by 7 liters per second. And this is in meters. This is in meter cube. R is in meter, so R cube will be in meter cube. Now see, for converting 1 meter cube equals 1000 liters. Remember this thing, 1 meter cube is 1000 liters. So volume of water to be emptied will be, let's suppose this is, I take this as Vm, this Vm into 1000 liters at rate of 25 liter per second. The total time will be required will be Vt by this divided by 25 by 7 liter per second. Calculate this, then solve the answer to get the answer. Now next question. They are simple. See, they have also done the same thing. They have converted this into liters and then liters to this. This is emptied in 1 second. Then this whole much will be converted in, divide this much divided by 2 by 7, and if you do multiplication, this the denominator will come in numerator and numerator will become denominator. 16.5 minutes. Exercise 13.3. A metallic sphere of radius 4.2 cm is melted and recast into a shape of a cylinder. See, a metallic sphere is melted to form a cylinder. Find the height of cylinder. See, R1 is given, R2 is given. We have to find H, a sphere. See, what is a sphere? This is a sphere. R1 is given something. Centimeters it is given. R1 is given. Volume of sphere will be 4 by 3. You know pi r cube, and there R1 this. Remember to write the units. Important. Now this is going to recast into a shape of cylinder having radius R2. This is cylinder, radius R2. V of cylinder is, you know, pi r square. Here R is R2, R2 square H, and this 2 will be equal. So for recasting, Vs equal to Vc implies that 4 by 3 pi r 1 cube equal to pi r2 square H. Pi to pi get cancelled. We have to find H, so H will be 4 by 3 r1 cube by r2 square. Solve this to get the answer. Simple. Now a metallic spheres of radius this and this respectively are melted to form a single solid sphere. Find the radius of the resultant sphere. Again same thing. 6, 8, 10. One sphere is this. No, one sphere is this. One sphere is this, and other sphere is this. These all are melted to form a bigger sphere. This is R1, R2 radii, R3 radii. Let us assume that this is R4 radii. Now this volume V1, V2, V3, and this is V4. See, volume 1 plus volume 2 volume 3 equal to V4. Why? Because we are recasting it. So what is volume 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube equals 4 by 3 pi r4 cube. Now you can see that 4 by 3 pi is common, so this get cancelled, which implies that r4 will be r1 cube plus r2 cube plus r3 cube root centimeters. I think this is given centimeter. Yes, centimeter. So centimeter. Solve this to get the answer. Now next, a well of diameter 3 meter is dug 14 meter deep. A well of diameter, this means radius is 3 by 2 means 1.5 meter, is dug 14 meter deep. The earth taken out of it has been spread evenly all around it in the shape of circular ring of width 4 meter to form an embankment. Find the height of an embankment. Same thing. Conserve the volume. Law of conservation of volume. See, this was a well. I'm coloring. This is sand. Now this sand. First, this well is dug for height h. Radius is r. Actually, diameter is given, so you can easily calculate radius by r is d by 2 formula. We have given r. Now this, suppose this is sand which is extracted from the well, is surrounded by it. See, at the ground level, since this is a well, so only top will be, you will be able to see only top of it. So I'm again drawing this. Suppose this is the top of, this is the ground level, this is the top, and embankment means you have to this. So you have to make this embankment. Now what is there? Diameter 3, height is 14, the radius is 1.5, 3 by 2, height is 14 meters. Meter, I think this is given meters. Yes, meter. Finally, around a circular ring of width 4 meter. This width, I will use this a different color. 4 meter wide. Now you know this thing. This is 1.5 meter plus this will be 4 meter. You have to find the height. This, how much height you can construct by using this sand. Now see, sand, the amount of the volume of sand you can extract from this well will be volume of well itself. What is volume of well? Volume of well will be, apply the formula pi r square h. Now this will be equal to the volume of this embankment. How will you calculate the volume of this? See, this is a bigger cylinder minus smaller cylinder, means pi r square h. H will be same for both of the cylinder, minus pi r square h. This r and this r is same. And what is this r? This r is small r, that is smaller 1.5 meter, plus 4 meter embankment. This, suppose I'll take it L. This is there. So if you and this will be equal to this. Now if you equate pi r square h, then yes, if we equate this to this h is different, h dash h, I'm taking this as h dash. H here is 14 meter and here you want to know what is h. So equate the two, is pi get cancelled, and for h this means r square h equals r square minus r square h dash. Never calculate in any time when you get r square minus r square or a square minus b square, never calculate a square and b square. You know a square minus b square is a plus b and a into a minus b. So h dash, I'm taking this reverse here, h dash equals r square h by r plus r minus c, r minus r. Solve this and you will get this answer, meters. Next, a container. Fifth question, a container shaped like a right circular cylinder. See, there are cylinder can be of two type. One which is a normal cylinder, you have not seen, but this is which is a right circular cylinder. This is a right simple straight right circular cylinder is this, where this angle is 90 degrees. What is the other cylinder? You can, this is here, this, or if this here, if you draw center to this center, this angle is not 90 degree, is a right circular cylinder. Question, right circular cylinder having diameter, this diameter is 12 centimeters, means radii is 6 centimeter and height 15 centimeters, full of ice cream. The ice cream is to be filled into a cone of height 10 centimeter having a hemisphere on the top. Any number of such cones. This you can say is a good question. Cylinder, this is r1 is given, this h is given, you can say h1 is we formed n number of this cone. This is r2, h2, and this is a hemisphere. This is a ice cream softy. Cones, this and this. See, now you are nothing. See, this is in centimeters. Find the number of cones to be filled in the ice cream. See, the volume of the ice cream in the cylinder will be equal to n into number of volume of this ice cream cone plus hemisphere. So volume of the cylinder will be pi r1 square h1 will be equal to n into what is volume of this hemisphere, 2 by 3 pi r2 square h2. No, sorry, this is for hemisphere. This is pi r2 cube, 2 by 3 pi r cube, plus for this cone 1 by 3 pi r2 square h2. See, r1 is known, given, h1 is given, pi are constant, you can simply cancel pi, you can even take 3 common out, but see, r2 is given, h2 is given, and for this is you need to find. So solve this and get the value of n. It is simple. Remember, n will be having no unit because n is a number. Next, how many silver coins? 1.76 centimeter in diameter. In diameter given, this simply means that radii will be diameter by 2, that is 0.825. It is divided by 2, 0.825 centimeter, and thickness this must be melted to form a cuboid of dimension this, and this. Same thing as in different way. In this question, bigger thing was melted to form n number of smaller things. In next question, n smaller things will be coins. See, this is coin, n number of such coins are melted to form a cuboid. See, cuboid, I am taking LBH, length, breadth and height, h. Coin radius I am assuming r, and thickness will be, see, if you can represent thickness by t also, but here remember that this t will nothing will but the height of this coin, and this coin is nothing but a cylinder of height t and radius r. N number of coins need to be melted to form this cuboid, which implies that volume of n number of this coin will be volume n into volume of one of the coin. When volume one of the coin, volume of a cylinder, pi r square h, here h will be t, thickness given the question, is equal to the volume of cuboid. What volume of cuboid? L into b into h. N will be L b h by r square t, pi r square t. Solve this and you will get the answer. And remember, n will be integer value and no unit. Next, a cylinder, 32 centimeter high and with base of 18 centimeter is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is this, find the radius and slant height of the heap. Same thing asked in different way. There is a cylindrical bucket. The cylindrical bucket, R1 H1, to form here it is filled with, completely filled with sand, SiO2. This need to be formed to a sand cone. You must have seen this in beaches where children used to play and create this. This has height you don't know. Let's take H2. Slant height is to be taken, let's say it's L, but R2 is given, radius is given, so let us assume this is H. Now what we are R1 is given, H1 is given, H2 is not given, L not given, R2 is given. See, volume of sand taken from this bucket is used to create this, which means conservation of volume. Volume of cylinder will be pi R1 square H1 will be equal to, what is volume of this cone? 1 by 3 pi R2 square H2. See, here we know this is constant, which means we don't know, we know this. Pi's, you can even cancel out 2 pi's. R1 is given, H1 is given, which we can calculate H2. From here we get the value of H2. Now you know the slant height relation, L square will equal to R2 square plus H2 square, Pythagoras theorem. Then L will be equal to R2 square plus H2 square, and if it is given centimeter, you write centimeter here and centimeter here. Solve this and get the answer. Next, the water is in a canal 6 meter wide and 1.5 meter deep, is flowing with a speed of 10 km per hour. It's flowing at one canal this wide and this deep. How much area will it irrigate in 30 minutes if 8 centimeters of standing water is needed? Water in a canal is 6 meter wide. See, water in a canal six meter wide, 1.5 meter deep. 1.5 meter deep. Flowing at a rate of this, how much will it irrigate in 30 minutes? See, here your length is not known. You only know this is flowing at a rate of 10 kmph, kilometer per hour. See, this is in meter, this is in meters, but this is in kilometer. First convert this velocity of flowing water in meter per second. This is 10, 1 kilometer is 1000 meters upon 3600. Because 1 hour is 60 minutes and 1 minute is 60 seconds. So meter per second. 0 this 0 gets cancelled. This is cancelled. This 10 is left. This 2, this 2, 100 means 100 by that. You can even cancel this also, but let us let it remain as it is. Now you are given question that in 30 minutes, how much it will irrigate, if 8 centimeter of standing water is needed. See, this is the canal. So in 30 minutes, since this is it is in meter per second. In 30 minutes, see, time 30 minutes equal to 30 into 60 is nothing, 1800 seconds. So how much water, volume of water will be flowing here? Will this is fixed, velocity is this, so at time this second, the length of, you can say that length of water will be 100 by 36 into t. 100 by 36 into 1800. Now you know why I have not cancelled it, because 18 1s are 18, 18 2s are 36, 250, 5000 meter. 5000 meter. So volume of canal, I am denoting BC, is, suppose this is B, this is H, L into B into H is equal to volume of the field to be irrigated. What is volume of field? Area into standing height. Let's suppose a height h dash, and h dash is given that 8 centimeter of standing water is needed. 8 centimeter you need to convert it into meter, which is nothing, 0.08 meter. This is h dash. Now area of the field you need to find. This is given. This product you can calculate from here, and if you equate the two, you will get the value of A, which is the answer. Now next question. A farmer connects a pipe of internal diameter 20 centimeter from a canal into a cylindrical tank. See, farmer connects a pipe of internal diameter this into a, internal diameter, but it must be that there might be an external diameter also, from a canal into a cylindrical pipe in her field, which is 10 meter in diameter and 2 meter deep. And 2 meter deep. If water flows through the pipe at rate this, how much time will it need to fill the tank? Same question. Speed is to be, you can say that it is like this. This is the farmer tank. Here he or she has connected this. See, everywhere they are giving diameter. You can calculate radius. Radius will be diameter by 2. Here this will be 10 centimeter, and since this is diameter of 10 meter, so the radius will be 5 meter. See. 20 centimeter. See, you first convert it 20 centimeter into diameter is 20 centimeter. Implies that radius equal to R1. You can say R1 is equal to 0.2 meter by 2, 0.1 meter. Suppose this is R1. Triangle which is 10 meter in diameter. 10 meter in diameter means 5 meter in radius, and the height will be given 2 meter deep. 2 meter deep. This is R2. You can say this is H2. Water is flowing at a rate of just 10 meter in diameter. This is the water flows through the pipe at rate of 3 km per hour. How much time will tank? Water is flowing from here going to here, here going to here. Total water flown from this pipe should be equal to the volume of tank when it gets fully filled. So need to conserve volume of water. Volume of water flowing through this pipe, connecting pipe, will be pi R1 square L1. What is L1? velocity of water into time. Velocity of water into time. This is velocity of water. You can say S is the velocity of water and T is time. If this is given, this is you need to find out. Equals volume of cylinder pi R2 square H2. Pi cancelled. Now substituting the value of L1 is S into T equals R2 square H2. S2 is given, R2 is given, S is given, speed of this, R1 is given, you need to find T is nothing, R2 square H2 by R1 square S. And C. S is in kilometer per hour. First you need to convert it into meter per second. S is 3 kilometer per hour equals 3000 upon 3600 meter per second, because every unit need to be same. This is meter. I have all converted this radius of the small pipe into meter, 0.1 meter. This is in meter, so this must be in meter in second. Solve this into and you will get the answer. Thank you for this lecture.